Welcome to all the participants from various organizations throughout Tamil Nadu. Today we would like to discuss about the flood hazard assessment using remote sensing and the GIS. Here I would like to give the first lecture. What are the basics of just 2 or 3 minutes brief introduction about the remote sensing, GIS, flood elevation mapping and damage assessment as well as hazard assessment. Here, first of all, you should have a good knowledge, at least a basic knowledge regarding the remote sensing. Just see here, in the case of just how to observe why the floods have been happening and what are the causes due to these floods. Just see here, the main causes due to floods are localized heavy rainfall, and another one is accumulation of runoff of heavy rainfall, and distinctive features and drainage condition at river and canals, shape of the catchment area, and shape and strength of river canals, and generally embankment issues. That means at the time of localized heavy rainfall, right now I would like to discuss about the river flooding, especially we have to discuss about the river flood. Just these are having some of the causes to the river floods. And just we have to observe the recent Chennai floods. Just to see the pictures of recent Chennai floods that has happened in Chennai. Just you can observe these figures. Just here, what are the areas also going to be provided at different parts of Chennai also. If you are observing the things, almost every part of Chennai has been affected due to localized heavy rainfalls. That's why we have to be, before going to understand these things, before going to understand these things, you should have minimum knowledge in the remote sensing and GIS part. Why we have to be carried out these things in the remote sensing and the GIS? In the case of remote sensing is part of science obtaining an information about an area or object or phenomena by utilizing the devices without any physical contact with the particular object. That means just you have to imagine your eyes and your ears. These eyes and ears have been working as a sensors. That means just you have to see, you have been observing the different lights and different people those who have been in this particular room. That means your eyes have been working as a sensor and your nervous system as well as your mind have been operating as a computer. Then automatically it has been observing the images through in and around you. That's why you have been taken as a remote sensing. That means it has been providing without touching of object. We have been acquiring the information about the total earth surface. That's why what is the use of this remote sensing and GIS in the case of flood hazard mapping or flood inundation mapping. That's why we have been providing the motivation why we have to be carried out this flood inundation mapping or floodplain mapping or flood hazard mapping in the remote sensing and GIS platform. The first one is computer automation in time and resource savings versus manual flood planning. Just to see here in the case of manual flood planning, just to simply they are going to be providing, just to see, I would like to say the manual flood planning. Just to see here these figures, just to simply they have taken the areas and simply they are going to be, these are the areas they are going to be providing the flood plains. But here my intention is not like that. My intention is, just to see here, flood inundation mapping, that means area with the depth wise also. That means what are the areas are going to be affected due to these floods and how much amount of depth of water level has been taking place in that particular area and what are the land use, land cover is going to be affected by that particular floods and how many number of people are going to be affected due to these floods. This type of things definitely has the flexibility in the remote sensing and GIS, because in the case of GIS part, that means geographical information system. In the case of geographical information system, it is having the flexibility to store the image, to start, to capture that data or to analyze the data, to manipulate the data. That type of flexibilities we have in the case of geographical information system. That's why time resources and resources saving with the manual flood planning and flood elevation area with the depth of water level. That means just you have to observe area with the depth of water level. Suppose you have to observe if 0.5 meter depth is to be there is no problem. If 1 meter depth is to be there, or 2 meter depth is to be there, or 5 meter depth of water level has been coming into your area, what is going to be happen? Tell me. If it is 0.5 meter depth, then is Chennai, no problem. And in 2009, in the river of Krishna, at the place of Kurnool, that is near Mantralayam, almost 2 floors have completely submerged with water. Just you have to imagine the things. 2 floors completely submerged with water. Such type of scenarios will be happen. Lot of property as well as human beings are also going to be die due to these floods. That's why identify the depth of water level. That means if it is 0.5 meter or less than 0.5 meter, there is no problem. If it is more than that, 0.5 meter or 1 meter or 3 meter, definitely the property is very high. That's why in the case of hydrodynamic modeling as well as remote sensing and GS, it is having the flexibility to identify the area with the depth of water level, and simultaneously you have the flexibility to identify the different land use land cover. That means what are the areas are going to be affected by these floods. That means in and around here we have lot of flexibility. That means we have habitats are there, we have water bodies are there, we have roads are there, we have agriculture areas are to be there, we have buildings are to be there. That means what are the areas are going to be affected due to these floods, how to be identified. That's why the motivation has been carried out with the flood elevation mapping or flood hazard assessment due to these things. Impact analysis and early warning systems are also going to be provided with the help of these things. That means impact analysis. That means you are going to identify what are the land use land cover are going to be affected. Simultaneously, you have the flexibility to identify the economic losses also. And simultaneously, how many number of people are also going to be affected due to these floods will also identified with the help of this analysis. And another one is flood early warning systems. That means flood early warning system will have to be provided with the help of flood frequency analysis. All of you are from civil engineering background, I think so. Yes? In the case of hydrology or as well as in the case of water resources, definitely the flood frequency analysis will come into the picture. In the case of flood frequency analysis, what it is going to be providing? The flood frequency analysis will provide about the future occurrence. That means what is the probability of occurrence of that particular event. That means if a 10 mm of 10 centimeter rainfall is happened at a particular area, during the period of 10 years, such type of event will be happen once in 10 years. In 100 years, such type of events may be happen 10 times. That means during the period of these 10 times, it may be happen for the continuous 10 years, or it may be next 10 years, or it may be last 10 years also. That type of information will be provided by T. P will be equals to 1 by T, where T is to be indicated as a recurrence interval or return period, reoccurrence interval. That means what is the possibility of occurrence of that particular event in the next 10 years, or next 1 hour, or next 2 days, next 10 days, or next 100 years. That type of information will be provided. Then this output will be entering into hydrodynamic model as an input. Then we are running these things with the help of hydrodynamic modeling, GIS and remote sensing. We are going to provide the flood elevation mapping as well as flood hazard map in the GIS platform. These are the basic things that are to be required. To do all these things, definitely how good quality of data should be required. What type of quality of data should be required to do the things in the remote sensing and the GIS platform. Just you have to imagine remote sensing. Remote sensing means you have been observing the area. That means suppose if it is a small area, you have the flexibility to observe these things. But if you are going to monitor very huge areas, it is not possible with the manpower. That's why suppose if you are going to identify the agriculture area, that means what is the crop yield in this particular year. If you are going to monitor such type of things, definitely you should require this remote sensing platform. That means you have been acquiring an information of earth objects without being in contact with that particular objects. Look like your eyes or your ears. You have been hearing and you have been seeing with your eyes. That means these eyes and ears have been working as a sensors. That means with the sensor, our computer brain will be working as a platform. Like satellites, they are having different types of sensors. The sensors, they are going to arrange to the different satellites. This, they are going to be monitored with the help of that sensors. It will pick up sensor. That means it will pick up the energy by two ways. One is by active remote sensing and another one is by passive remote sensing. In the case of passive remote sensing, the main energy source is electromagnetic energy. Sunlight energy is the main resource for this one. Okay? Just see here. To do these things, the flood hazard mapping or flood inundation mapping, what type of data you ought to be required? The data requirement is Survey of India topo sheets, and another one is satellite images and a digital elevation model, and another one is river cross sections, stage and discharge level, rainfall data, and field service are to be required. All of you are civil engineers, that's why all of you are very familiar with these things. Rainfall data, generally the rainfall data is measured in the IMD, Indian Meteorological Department. Stage and discharge data. The stage and discharge data, stage data is the depth of water level that is to be measured in the form of meters, and the discharge data, is cubic meter per second. The discharge and stage data, that it has been maintained by Central Water Commission. And another one is to identify the topography of that particular area, you should require the Survey of India topo sheets. And another one is very important information is digital elevation model, that is DEM. We have different sources of DEMs we have. That is SRTM DEM we have, and we have Cartosat DEM from India side. From Indian remote sensing satellite, we have the flexibility of Cartosat 1, that is having the stereo pairs we have. That stereo pairs is having the capability of up to 7.5 meter vertical resolution it is going to be providing, and horizontal resolution it has been providing 2.5 meters. That means a 2.5 meter resolution means it is going to be providing, just to see here, the pixel sizes. Just to see, if you are going to observe any figures, this will provide the resolution of any picture. That means that it will be provided, indicated by digital numbers. Every pixel, just if you are going to observe your TV, television, at the time of no signal, you have been observing some of the pixels on your television screen. Have you observed any time? Have you observed any time? Just as pixels, nothing, no data is, no pictures are to be available, only some small pixels are to be identified. Have you observed? That pixels are to be treated as those pixels. That pixels are to be having, each pixel is having some digital number. That is to be taken as DMs. The range of these digital numbers are to be 0 to 255. Those values are to be indicated by the resolution of any image. If the resolution of the image is very high, that means if you are going to observe any Google Earth maps, if you are observing Google Earth maps, you have the very good flexibility to observe the things. You have been observing your home or your fields in the Google Maps also. That means the resolution is very high. That means nearly the resolution of each pixel. That means the pixel resolution is to be nearly 1 meter by 1 meter. This is 1 square meter area. That's why we have the good flexibility to identify your agricultural fields and your homes also at your end. Okay, that is the thing. This is about the different data requirements. The data requirements are to be provided to certain topo sheets, Survey of India topo sheets. Survey of India topo sheets will be available at state headquarters, and the satellite images you have to be procured from the NRSC, National Remote Sensing Service Center, and some of the things are also freely available. Another one is digital elevation model. That means digital elevation model. That means the elevation of Earth surface. That means just you have to observe the Earth surface is not in a flat condition. Yes or no? Obviously, it is having the different undulation areas. That means if a drop of rainfall falls at a particular place, in which direction it is going to be moving? Obviously, in low-lying areas. Yes or no? That means the system is providing digital elevation model. That means automatically every pixel is having some elevation. That means if you are going to provide a water drop on that, it is obviously automatically moves in that direction. That's why digitally has been providing elevation values. That means every value, every pixel is having one elevation value. That's why due to these things, the digital elevation model plays a very important role in the case of water resources management. To do the reservoir analysis, to do the dam break analysis, to do the flood frequency analysis, to do the flood inundation mapping, to identify the damage assessment. Definitely you should require a good quality of DEM. The DEMs from USA, we have SRTM DEM. SRTM means Shuttle Radar Topography Mission, and Cartosat 1 DEM. The SRTM DEM is having the resolution, vertical resolution is right now for India, it is 30-meter resolution is available. And for Cartosat India, we have the resolution of 10 meter. That is having a very good quality of DEM we have been providing. Due to those things, we have developed the flood elevation mapping and flood hazard assessment for the Subarnarekha River. Just see one case study how we have developed the flood elevation due to utilizing all this data. Field service, once I went to field at Subarnarekha River, just you have to imagine that is located at Yarrakula. At the upstream condition, the width of the river is nearly 200 meters. At the downstream of the river, the width of the river is nearly 4,000 meters. Just you have to imagine 4 kilometers. Is it possible to identify to survey the cross section in one day? Suppose if it is 200 meters, you have the flexibility to go and identify the field survey. But if the river cross section is 4 kilometers, is it possible to identify, to complete the survey of that particular cross section in one day? Obviously, you do not have the flexibility. But here, you have the flexibility. Just simply, you have to make one line, obviously and automatically, it will provide the elevation information. That means how the river cross section is to be located at that particular place will be provided with the help of this particular digital elevation model. That's why automatically all these things you have the flexibility to do flood elevation mapping as well as hazard assessment will be carried out in the GIS platform by utilizing the tools of remote sensing and GIS. Just to see, for this purpose we have taken the case study of Subarnarekha River. The Subarnarekha River has been originated at the place of Ranchi, Nagari village of Ranchi district in Bihar at the elevation of 600 meters, and the total length of the river is nearly 395 kilometers. That means this is a Chandil Dam. Once I think so in 2004 at Chandil Dam they have released nearly 2 lakhs cusecs of water at a time without giving any information to the downstream areas. Just to see, this is an interstate river. In the case of that river, it has been started at Bihar, Jharkhand, next it is in West Bengal, and downstream areas it is Orissa. Here, then it is entered into Bay of Bengal. And here, this is located, this Chandil Dam is located at Jharkhand. They have released a huge amount of water without giving any intimation to the downstream areas. Simply what happened at the place of this is very low-lying area. This is located at Jamshedpur at West Bengal. Simply nearly 100 to 200 people were dying at that condition. That means a lot of overflow of the river has been taking place and heavy floods was happened at the time of night. That's why before going to release the water, just at the place of reservoir or dams, definitely you should give an intimation to the low-lying areas. Then the people are having the position able to evacuate at that particular place. That's why we have been taking this as a case study to develop the flood elevation mapping as well as a damage assessment. Just to say, our objective is to identify the analysis of water level and discharge. And another one is the forecasting of future flood events. Forecasting of future flood events means which is about the flood frequency analysis. All of you are from civil engineer, definitely you have knowledge about the flood frequency analysis. And third part is assessment of floods. Assessment of flood in in the case of damage assessment as well as flood hazard assessment also. Damage assessment is different from hazard assessment. Yes, you have to imagine. Damage assessment means we have to identify the past flood events. Past flood events. That means before how the floods have been occurred, we have been monitoring the water level and discharge, and we have assessed the damage for the each land use land cover. And we went to the field and we identified where the areas are going to be occupied by the water in that particular